Viewers like you make this program possible. Support your local PBS station.
Although we see energy resources as transforming the standard of living, comfort has this really dark side as well.
Ever since the Industrial Revolution, there have been accidents.
A black avalanche slid onto the houses and the street.
11 are missing. Where's the search for them? How is that being concentrated?
There is some level of danger associated with every form of energy. There's always the potential for something to go wrong. And that danger is exacerbated when things get more complex.
Energy enabled many good things. It made us more comfortable. It made us safer.
And it is a solution to many of the world's challenges. But energy, because it has great power, also can be very dangerous.
And the story of energy includes a lot of disasters over time.
These are tough industries. There's often dramatic loss of human life. Studying, learning about, remembering energy disasters is absolutely vital to more responsible and greater use of energy.
With every disaster, we learn things. As each failure occurs, we get more insight into how failures might occur.
We will always rely on energy. For that reason, we have to continue to carefully manage it. Energy can be produced safely. The danger of it is why it's a highly regulated industry. But when things go wrong, there's always lessons to be learned.
To understand ourselves and each other, we must understand the force behind the global events that shape the world. This is Power Trip, the story of energy. Earth is full of untapped energy, hidden deep underground, or in a waterfall, or disguised in a cool breeze. Our living planet makes its pulse heard throughout history with enormous displays of energy. We often call these natural disasters. Our modern energy has allowed us to save countless lives in response to these disasters. But this was not the case for much of human history.
In the pre-industrial times, life was very hard and people didn't live very long. Every weather event was potentially a killer. Imagine a volcano in an era where you don't have electricity or clean water. You have no way to call in for help.
There's definitely a sense of traditions holding on to the culture and the history in Iceland, because it was very difficult to make a life on this rock in the North Atlantic.
Iceland has this natural history. It is the first New World experiment. We can go from day one, and we have written accounts of it, to the modern day.
I think there's something noble about the fact that we've managed to survive on this island for 1,000 years. This is a replica of a house in the age of settlement, so about a millennium ago. They made their houses out of sod and grew grass on top as basically a form of insulation, keep warm.
Icelanders have throughout the ages relied a lot on our natural resources. Iceland was settled in the 9th century. The settlers clear-cut the forest to make pasture land. They burnt the wood for energy. As the country was deforested, the soil was degraded, and we didn't have that source of energy anymore. Then people would use either peat or actually dried lamb dung as fuel, as a source of heat, and also of a delightful aroma.
As an island, I think we have a rich tradition of just making use of the resources that we have around us, because oftentimes there's just not a plan B.
Iceland is an amazing story from an energy perspective. Isolated so far away, living on the edge of disaster at all times.
Our environment is pretty threatening, whether it be volcanoes or glaciers or raging rivers. We move merrily along in the light of natural disasters.
In Iceland, people live side by side with some of Earth's most powerful displays of energy. The saga of Iceland is both a lesson in the rewards a society can reap from the resources around them, as well as a sober reminder that nature can give or destroy.
The current eruption that we have in Fagradalsfjall is of the tourist variety. It's an attraction. You know, people like to come and visit it. Nobody is in great danger. It's not causing any economic disruption. But that's not always the case. Magnitude and significance, the largest eruption in Iceland was in Laki.
Laki took place in 1783 to 84 and lasted for 8 months. Volcanoes like Laki release a significant amount of fluorine into the atmosphere in the gas form.
There was a famine associated with it called móðuharðindi. It means the haze famine, because all the noxious gases caused fluoride poisoning in grasses.
And at that time in Iceland, their livelihood was the livestock, and they basically starved to death.
1/4 of the Iceland population died not from direct contact with the volcano, but because of famine. People had to resort to mass graves because they were just too weak to bury the dead. The Laki eruption was really the first time in Iceland's history that this island that people knew vaguely about in the 18th century was on everyone's minds and lips. The effects of that eruption were so devastating that they were felt in Japan and Egypt. Europe was under a cold spell for 2 years. There was ice in the Gulf of Mexico. This was like a climate apocalypse.
Most of the northern hemisphere was covered by a haze, or what people referred to in those days as dry fog. Benjamin Franklin was in Paris in France. One of the things he realized is that dry fog was actually reducing the amount of incoming solar radiation. And the way he demonstrated that is actually he took a magnifying glass and then he focused the solar beam on the piece of paper, and as you normally do when you want to ignite it. But he couldn't ignite it.
Today, when tour guides drive through the lava, they point to it and say, this is where the French Revolution started. When Marie Antoinette told the population, let them eat cake, she was referring to the price of bread, but no one could afford it. And you could trace some of that to the eruption of Laki. When the climate changed, it caused crop failures across Europe. The French Revolution probably would have happened, but it would not have happened maybe at that particular time. When you go to that lava, you should thank it for the birth of modern democracy.
The Laki eruption in 1783 caused the death of 1/4 of Iceland's human population, and the fog covered much of Europe. The following winter was one of intense cold, blizzards, and heavy rain. An untold number of people froze to death. It was a natural disaster amplified by the lack of modern energy resources to aid those in need. And at the same time Laki's deadly haze spread across the globe, scientists and inventors in Great Britain were making the breakthroughs that paved the way to our modern energy.
When the Laki volcano erupted in 1783, energy at the time was still primarily biomass. If you look at France, they had a lot of falling water. So they use water mills and water wheels to do their industrial work. And in the Netherlands, they had flowing air, so they used wind wheels or windmills to grind grain or cut wood or polish glass. So you look at each country and they use the resource they had, whether it's the wind in the Netherlands, the falling water in France, or the coal in the UK.
At the end of Elizabeth's reign, England is a little peripheral country on the edges of Europe. By 1870, it's the richest, most powerful country in the world. How does this happen? Coal.
One of the questions with this is, could we have done what we've done in the last 200 years by cutting down trees and relying on getting whale oil from the South Atlantic? nowhere near. You could not sustain an industrial revolution just using wood or whale oil. Coal was important because the intensity of the energy which you could extract from it. People realise just the quantity of coal that they're sitting on. You know, there's surveys across the country. They produce these amazing maps of the whole of the UK, and they're really just saying, wow, I mean, we can keep mining this for a very, very, very long time.
Britain is really a lump of coal in the North Sea. Once we get the exploitation of coal, dramatic things happen.
Britain surges ahead of other countries. It becomes vastly more wealthy. In fact, scholars call it the Great Divergence because Britain leaps ahead and is able to then build these trade networks all around the world that further enrich it and empower it as a giant empire.
But here is the sign and symbol of the new order, steam and smoke. There is power behind it, and behind the power is coal.
When you were powering ships or vehicles with steam, you obviously need the best coal. The Welsh coal in particular was the best steam-generated coal in the world, particularly in West Wales, where you had the anthracite coal, which is the harder coal, nearly diamond.
We kept the Royal Navy going. The Titanic had Welsh coal on it when it sank. The rest of the UK thinks that all Welsh people were singing, miners, you know, playing rugby on the weekend and what have you. But it is a huge thing. One time, 3/4 of the population was either directly or indirectly connected with the coal industry.
When the coal industry is actually at its height in the UK in 1913, there's 1.1 million coal miners. These areas and their communities and their people gave a very significant advantage to the economy at great cost to themselves.
If you drive around Wales, you'll see statues and these plaques, memorials to the people who died in the Welsh mining disasters. These memorials are a way to honor the people who died, trying to lift the economy out of poverty, to lift their friends and neighbors and family members up in the world. And that's why we need to remember them.
The U.S. government defines a mining disaster as one in which 5 or more people died. By this metric, there have been hundreds of coal mining disasters in the industry's history. Disasters continue to occur today in some parts of the world still reliant on coal. In the early days of the industry, it was the people of Wales who took on much of the burden of learning from mining disasters.
There's around 152 disasters in Wales over the last 150 years, from about 1856 right through to the 1990s.
In many of these Welsh mining towns, like Sengeneth, the mine is the biggest employer and the central piece of the local industry. And so when you have a disaster, not only does it really upend the local economy, it kills neighbors and friends and family members and colleagues.
The worst disaster was in 1913, which was at the peak of what South Wales was exporting the same year. 439 people died in a single incident. I don't think anybody really knows, but they think it was a spark ignited from a stone. Our coal is very gassy. Each seam has got its own gas content built into the coal, so as you mine the coal, it releases the gas. And I mean, all you need then is a spark and bang.
Half the pit got wiped out. Not just from the initial explosion, but from the after damp, which is basically carbon monoxide. So the majority of the people were actually suffocated to death underground. Down to 12-year-old, that's the starting age. Then up into their 60s, still working underground. I don't think Sengeneth really recovered since then. You've still got that feeling that something awful happened here.
The men who died, they must never be forgotten. The valley wouldn't be here if it wasn't for the coal. That's the whole thing about the valley.
I mean, it was a working pit by 1900, and it closed in 1928. Only 28 years, but it managed to kill 500 men while it was open.
William Harris was my grandfather. There he is after the explosion. My grandfather was the only survivor of the 1901 explosion.
And he only survived because he was a hostler, right, Jean?
Yeah.
And he happened to lean down by his horse, and the horse took the full blast, not him. It's been very difficult because, see, not long after the disasters, we seem to be forgotten because the First World War started. And of course, in the first day of the war, 5,000 men were killed on the Somme. So we just faded into insignificance. But, not now, not now. We fight our way back now. The price that was paid for coal must always be remembered.
It's always important to check on the reasons for disasters, wherever that disaster is. After every major explosion, since the 1850s anyway, there's always an inquiry into them, which they actually look in great detail at what happened. So hopefully you can learn something for the future. This is what they would have been wearing underground from around 1900, right up basically till the 1930s, 1940s. No helmet. The scarf around his neck is for dust, so when he's working in dust, he'll put it over his mouth. On the front of his cap is a peg and ball lamp, which is basically a simple naked flame oil lamp. And the tobacco tins themselves are interesting because they normally stamp with the owner's name, the collar he worked, or, stuff like that. So safety involved over the years, obviously, and this is where you're ended up. This is probably the ideal miner, if you know what I mean. Steel toe cap boots. He's got greaves on the ankle. He's got orange overalls with reflective bands on them. On his head, he's got a helmet, which the lamp fits on. Ear protectors, eye protectors, and also a dust mask around his mouth. Still got a tobacco tin. By 1961, we thought, okay, all this legislation's in place. But almost at the end of the industry, you had Tower Colliery explosion, you had Six Bells explosion, you had the Lewis Merthyr explosion, you had the Cambrian explosion, all still happening. Aberfan disaster was because the industry had never regarded tipping on a mountain as being a problem. When they produce coal, they've got to have somewhere to dump the rubbish, so a lot of the stuff is actually tipped on the mountain. Now, tip number 7 in Aberfan was one of a number of tips for Merthyr Vale Colliery, and for some reason, whoever formed it first put it on top of a stream. The tips were on the side of the valley. The colliery itself was in the bottom of the valley. Between the two, there was the village of Aberfan. October 1966, about 9:15 that morning, the tip blew out in the middle. Half of it just broke away and headed down into the valley.
Banqiao was the local primary school, and for generations every village family sent their children there. 3 classrooms disappeared, buried underneath 60,000 tons of slurry.
When I went back up the steps and looked, it was horrible. You knew that nobody could have come out from that bottom end.
Tipping had to change. A lot of tips were removed all over the country, all over the world. The safety and the culture all improved because of all the disasters we had.
The coal industry, it's one of the first industries to develop a safety culture because of the amount of people who could get killed for very simple reasons. Introduced PPE, and then of course it's adopted by other industries. If you go up the motorway, you think there were miners everywhere, weren't they? Because they all got orange overalls and white helmets. When the coal industry basically shut down in the late 1990s, it was the safest coal industry in the world.
I think a lot of the coal industry has been erased from memory since the mines have gone. The valleys are green again, It's difficult in parts to imagine what they were like even in my childhood, where coal was king, really. But when you think of all the human beings which built the valley, it was built on coal, and it was vast. You've got to maintain respect for the dead and the memory of the dead and what they represented. Hopefully you learn, innit? Hopefully mankind will learn from these things and do it better, innit, next time. The Guardian is a memorial that is there to remember a lot of the major disasters that have occurred in the coal mining industry throughout South Wales. You've got the stature of a miner, but he's looking to protect. I always think the doom and gloom of the story is not all the story. Prior to 1840, the valleys had no people, a couple of farms. And then by 1910, urban development, houses everywhere. The people came there to work and live, you know. The Guardian represents the strength of miners. It represents the community. It also represents like a guardian looking after his dead. But there's something, big about him, innit? You know, it's powerful looking guy. Like.
We often think of the rundown of the British coal industry as being associated with political events of the 1980s. But this was not only political. Also, there was new sources of fuel energy.
Humans have benefited from crude oil for millennia, and today, oil is refined and distilled into innumerable products used in every facet of life.
Our society essentially runs on petrochemical fuels. And it's been one of the big drivers of our societal technological gains. It's not free. We know the consequences to fossil fuel burning pose enormous hazards, but it has high energy density, 44 kilojoules per gram. That's an enormous amount of energy.
Coal helped lift us out of poverty with the Industrial Revolution. Oil lifted us even further and then gave us great freedoms because it gave us mobility. Oil is a better transportation fuel because it has such great energy density. It doesn't take much liquid to get a lot of energy and move a car a great distance. And it's easy to store, it doesn't freeze very easily, it doesn't boil away.
Even though the old oil lamp is a thing of the past, oil still helps light up America.
But drilling for and extracting oil and gas is inherently dangerous. There are just a lot of things that could go wrong on the site. It's big machines dealing with heavy rocks and high pressure, and the fuels themselves are flammable and explosive. As we use more oil, we needed to find more oil to get the energy out that we could use for our cars and for our factories. So we started to explore the world for oil and gas deposits offshore. These offshore locations have their own risks. It's just really hard conditions to work offshore, and more can go wrong. And because these are large deposits of oil and gas, the consequences are larger.
120 miles northeast of Scotland, at 14,000 tons and 2.5 times the height of the Statue of Liberty, it is one of the largest rigs in the world.
In the Piper Alpha accident, over 150 people died. Piper Alpha, it's been studied enormously because it was sort of a series of steps in terms of maintenance, human action, in terms of specifications and guidelines that seem to have all failed. Fire on the Piper Alpha was started because of a fuel leak. The fuel mixed with air created a flammable cloud, found an ignition source.
The Piper Alpha exploded and sank on July 6, 1988, killing 167 workers on board. It took over 3 weeks for the fires to be extinguished. 30 of the bodies were never recovered. A public investigation made 106 recommendations to help prevent future incidents.
look at the merchant marine educational process, or if you look at the Navy, the assumption is every sailor is a firefighter, because if a fire occurs on a ship, you have very few opportunities to escape, for example, other than to fight the fire and to try to suppress it. Typically, we think about the thing that kills or hurts people in fires as the burn. It's actually smoke inhalation that kills people. And so after the accident itself, reconstruction and analysis determined that most of the people died because of smoke inhalation hazards also. It's not really clear that there are things to mitigate smoke inhalation hazards in the absence of respirators, but the pre-planning of what to do once that alarm went off was missing. With that escape plan and better pre-planning for that accident, more people would have lived.
Safety culture develops in response to accidents that cause a lot of people to die. The deaths are horrific. They are emotional. They're expensive. In fact, today, if you go to an oil and gas company, they will start every meeting with a safety minute to remind you where the exits are and what you need to do to be safe if there's an emergency.
The global thirst for crude oil has resulted in thousands of oil spills over the years and large-scale environmental disasters. In January of 1991, Iraqi forces attempted to prevent American soldiers from landing on Kuwaiti shores by intentionally causing an oil spill that spread across 4,000 square miles of the Persian Gulf. In Mexico, a state-owned petroleum company was drilling an oil well when a blowout occurred. In Russia, a poorly maintained pipeline caused a massive oil spill, where millions of gallons flowed into streams, fragile bogs, and marshland. Deepwater Horizon oil spill began when an oil well in the Gulf of Mexico blew out, causing an explosion on the Deepwater Horizon rig, which killed 11 people.
In some sense, what we can learn about previous accidents is how to minimize the negative consequences of technologies as they evolve. Fossil fuel as a technology in terms of safety has improved enormously. An example that we all see is a gas station. Gas stations should be incredibly dangerous. Gas stations are incredibly safe, and it's because of the layering of safety after any given accident. It's like, oh, we didn't anticipate someone doing that. Eventually, these standards are developed, then the issue becomes the human factor.
If you look at the history of humankind use of energy, we started with things like windmills, and then we graduated to fossil energy. Nuclear showed itself as a natural next step to provide sustainable energy for humankind. Splitting this uranium nucleus generates the fission reaction on the order of 100 million times more energy per unit volume than fossil energy.
One of the ways in which nuclear energy is different in its origins from other sources of energy is that the underlying technology is very much dual use. Unfortunately, it was the weapons that were developed first.
Nuclear energy was born out of this violent era of World War II. So it always had a negative image.
The first thing we would know about it would be the flash. And that means duck and cover fast, wherever you are. There's no time.
1953, Dwight Eisenhower went to the United Nations General Assembly and made his famous Atoms for Peace speech, in which he proposed that the United States would share its knowledge, its technology, and uranium. We believed that nuclear energy could be a force for good. When the atomic age began for civilian nuclear power, the approach that we had towards safety was mostly to focus on the design of power plants. What we have learned is, if you look at the spectrum of accidents, there's a clear human element.
But a government official said that a breakdown in an atomic power plant in Pennsylvania today is probably the worst nuclear reactor accident to date.
At about 4 o'clock in the morning, the reactor shut down due to problems in maintenance that was being performed. The reactor began to heat up, and a relief valve opened to relieve pressure that was building up. That valve stuck open. If the valve was closed, pressure should have been maintained, but it kept dropping. And they didn't understand why. And that led them to make mistaken decisions to turn off pumps that would have kept the core covered in water and kept it cool.
The byproducts of nuclear fission ends up being naturally radioactive. This radioactivity shows up as heat. We always have to have some kind of a flowing water that continues to remove this heat.
If you don't remove that heat from the reactor core, then you're in danger of actually melting the fuel, which can be potentially catastrophic.
2 water pumps that help cool reactor number 2 shut down. Some 50 to 60,000 gallons of radioactive
Public basically suffered no health exposures whatsoever, and it led to a real tightening up in terms of the safety regulations.
Public support for nuclear power after 3 Mile Island dropped dramatically. It was unsettling for the public to see the Nuclear Regulatory Commission seemed confused about what was going on. So it was a crisis of confidence.
With 3 Mile Island, the fact is that the human operators did make a number of mistakes, which eventually the engineered systems overcame. Chernobyl, very, very different. First of all, a reactor that never would have gotten licensed in any Western country.
If you have a government entity regulating safety at the same time that it's government ownership, there's really no good adversarial relationship. That tension does lead to safety.
At Chernobyl, the plant operators were carrying out a series of tests on the safety systems. The way in which that test was executed interacted with a flaw in the reactor design itself. It led to a buildup of pressure in the core, a steam explosion, the fuel itself in the core melted. There wasn't a containment structure around the Chernobyl reactor.
It took a full 18 days before the Soviet leader Mikhail Gorbachev made any public pronouncement on the nuclear disaster at Chernobyl.
Where things really went wrong is beyond the plant itself. The bureaucracy, stretching all the way to Moscow, I suppose, made a series of bad decisions. They delayed evacuations. They didn't inform the international community. That turned what would have been a very serious accident into something that was truly a disaster.
The Chernobyl accident was at a reactor that is fundamentally different than the technology we use in the United States. Nevertheless, the NRC did an extensive review of our operations here. Ultimately, we determined that ongoing programs, especially because of 3 Mile Island, largely captured most of the questions that were raised because of Chernobyl.
A lot of work went into this human-machine interface, training operators to make the right decisions under unforeseen scenarios. But as these 400 plants across the world accumulated experience, what turned out to be true is that actually the events that happened within the reactor are not the ones that you should worry the most.
I was born and raised in Koreama, Fukushima. I've experienced earthquakes from childhood, but it was an order of magnitude different experience. We lost the power just after the earthquake.
In a nuclear power plant, the safety systems need the power to be on. But one of the first things that happens in a natural disaster is a power outage.
Once the tsunami hit, backup diesel generator got flooded, and then we could not circulate the coolant.
If you look at 3 Mile Island, Chernobyl, and Fukushima, they're really all so different. With Fukushima, the problem was not the operators. It was not the engineering of the nuclear power plants. They had a 1,000-year tsunami, which just came sweeping over the plants.
Because there was radioactivity being released to the environment, the government decided that it was prudent to evacuate. An historic earthquake and tsunami has taken place. During that rushed evacuation, many people lost their lives.
Nuclear accidents anywhere tend to have an everywhere kind of flavor. I was Secretary of Energy, and I did visit there in late 2013, helping with the environmental cleanup, the groundwater cleanup, but also understanding the accident, looking at some of the remedial steps that could be taken. And that leads to another set of innovations going on today. Technologies which are essentially immune to those kinds of accidents.
There is a bit of a silver lining. Each disaster altered the trajectory of the industry. Hopefully, every successive accident will be much less serious than the previous ones.
In the US, there's 2 reactors being built in the state of Georgia. Those reactors already have built in those passive safety systems that doesn't require any electricity for the heat removal. And so those plants actually would sail through a Fukushima type disaster with no issue.
Very few people have actually died from nuclear energy, so it's one of the safest options we have. But it's scary for people.
I don't always know how to respond to the question of, is it too dangerous? Yes. When new countries decide that they want to build and operate nuclear reactors for the first time, they are potentially developing the capability to make a nuclear weapon. And so this is why nuclear energy is very tightly regulated, not just from a safety standpoint, but also from a non-proliferation standpoint. But there is also a significant potential for good.
Nuclear is so promising because it has supreme energy density. And it doesn't generate air pollution, and it doesn't emit greenhouse gases. When people think of nuclear power, they think of these hyperbolic towers that have these plumes of what looks like smoke. But actually, that's not smoke, that's just water vapor. The pollution from burning fossil fuels is itself an energy disaster that kills millions of people a year.
In China, there is a tremendous amount of air pollution and water pollution that is directly associated with fossil fuels. Reports suggest that breathing the air in Beijing on an average day is equivalent to smoking 40 cigarettes. The rates of cancer have gone through the roof over the last 20 or 30 years. It's a disaster from a public health perspective.
That air pollution globally is a killer. 7 million people a year die prematurely from air pollution. But in the end, it's better to have energy or else everyday life becomes a disaster. We think of disasters as an incident, an explosion, a fire, a mine collapse, but there's also the disaster of climate change, where it unfolds over centuries. Nuclear is so promising because it has supreme energy density, 20,000 times more energy from a kilogram of nuclear fuel compared to a kilogram of coal, much more energy than you get from oil or gas. It's just so much energy in so little material. But also when you react it and then you use the fuel, it doesn't generate greenhouse gases. It doesn't generate acid-forming gases. So if you have nuclear power, you're not getting acid rain, you're not getting climate change.
There is no completely risk-free source of energy. Hydroelectric power is central as a renewable source of energy and is cleaner than fossil fuels. In most cases, hydroelectric power is safe. But while hydropower brings us massive benefits, it's not without its risks. Hydropower is the renewable energy source with the highest accidental deaths, largely because of a single catastrophic event.
In the late 1800s, there was the rise of a bunch of electric appliances, things like light bulbs and motors that were really good for life, and that required the need to generate electricity. As a country, if you have mountains and a lot of falling water, like the Fox River in Wisconsin or Niagara Falls, you can dam it up and harness that power to generate electricity we could use for these electric appliances. And that led eventually to a dam building frenzy. In the United States, a lot of the dams were built by the Bureau of Reclamation or the Army Corps of Engineers, two big federal government agencies. They could say, we're going to build a dam, we're going to do it here, and they didn't really care who they were going to flood or have to push out of the way to get it done. The dam building frenzy followed in China.
Through the ages, waters from the mountains have been fed to the fields of the valley. For here, irrigation is one of the ancient arts. For centuries, the muscles of men have raised the water as needed for crops that have never failed.
Immediately upon coming to power in 1949, Mao Zedong looks around and sees a Chinese nation that is dominated by household farms with people producing just enough to feed their families. And he says, this is no way to build a modern superpower. So at first he says, well, this is a 100-year process where we're going to catch up to countries like Britain, the Soviet Union, the United States. But starting in the 1950s, Mao says, actually, we should do this within 15 years.
Within China, Mao Zedong draws up a ruthless program to change an agrarian nation into an industrial power. He will move whole villages and set up communes.
This eventually becomes the Great Leap Forward, which officially starts in 1958. China wanted to build dams for a whole host of reasons.
This map gives some clues to China's great problem of being able to feed its 500 million people. Much of China is mountain, desert, infertile soil. The great river valleys are often subject to disastrous floods, and the population is growing at the rate of several millions a year.
Mao sets down these targeted plans about output, and it's all quantitative. It's how much earth are you moving? How much cement are you producing? And that's how you ultimately get fed. You know, you get your food ration by producing your quota of output. And so it causes all this kind of cheating among a population that also has no prior experience building something as massive as a dam.
Between 1950 and 1979, approximately 87,000 dams were built in China.
The Banqiao Dam is a microcosm of the problems of a central planning project like the Great Leap Forward. The Banqiao Dam is one of a number of dams that's built in the 1950s, but the scale was just unprecedented in China's history at that point. It's a massive undertaking. It requires thousands of workers, in many cases digging literally with shovels and their own muscle power to try to build this humongous dam. The Soviets provide technical expertise, but there's a number of flaws. There was an engineer named Chen Xing, and he was one of China's leading experts on how to harness hydropower, how to build dams. Chen Xing said, we need to have more sluice gates, the kind of overflow gates that allow water to pour through so that if there is some massive weather event, tremendous rainfall, that the dam isn't overwhelmed. He wanted 12 of these sluice gates. They ultimately ended up only building 5 of them. He tried to warn people, and he was silenced and taken off the project. Where there's a culture of silencing, of criticism, an inability of people to say, hey, wait a minute, this is not being done with the proper safety precautions, it just sets itself up for a massive disaster. In 1975, there was a typhoon that only comes around once in a millennium. Some people say that the raindrops were so large that it was killing birds that were trying to fly through it. It was just a tremendous amount of rain concentrated in a small amount of time. And it completely overwhelms the dam. The dam breaks. Being in the path of that water would have probably felt like the end of the world. A wave the height of a tall building coming at you at the speed of a car. And there were a number of villages, small cities that ultimately get washed away.
The Banqiao Dam disaster is the single worst energy incident in the history of humanity. In addition to the hundreds of thousands of people who perished, more than 10 million people were displaced by that dam collapse. But it was a secret for a couple decades. It happened in the mid-70s, and the world didn't know until the 90s. That's how close the information was coming out of China.
Hydropower has long been harnessed to produce electricity. It has evolved into a fixture in energy production, currently supplying 1/6 of the world's electricity. We often take it for granted that energy will be available to us. But power plants, power lines, gas lines, even whole power grids can fail. Disruptions to our energy systems, whether by sabotage, negligence, or natural disaster, can be deadly.
It was probably 2 or 3 o'clock in the morning when we were woken up by the gust of almost 200 miles per hour winds.
Knocking out power everywhere. All of the electricity is out tonight.
After the hurricane, the biggest toll was not directly the result of the winds or of the storm. It was people who did not have access to the bare necessities. Blackout leaves a lot of people without water because the water treatment plants needed power. After a few days, everything spoils in your fridge, or you eat everything that you have, and then you need to go out and get food. Communications collapsed completely. Banks were closed for more than a week. If you had no cash, you could not do any transaction. The blackout started to be hours, days, into weeks. Weeks turn into months. 4,645 people died. The mortality rate in the 4 months after Hurricane Maria raised by 62%. And ever since, what we've experienced is constant blackouts.
In Texas, it's a full-on humanitarian crisis.
People are just fighting to stay alive after a weather disaster has knocked out power to millions of people.
In February of 2021, much of North America was hit with a very severe cold snap. And what was unique about that storm was that it lasted for over a week of continuous freezing or sub-freezing temperatures across the entire state. Power plants in Texas started to falter.
Those that own and operate power plants in Texas are prepared for extreme heat. They're less prepared for sub-freezing temperatures. There's a popular narrative that this was the result of the failure of wind and solar farms. That is not true. You saw coal piles freeze, you saw coal plants trip off because they couldn't get the necessary water intake. You saw gas plants fail because wellheads froze off. There was a nuclear plant that tripped offline. There were fluctuations in the availability of wind and solar. And so all of a sudden, faced with the reality that there was so much generating capacity offline, the Texas grid operator had to call for utilities to cut power to customers to keep supply in line with demand.
Our water system relies on electricity to pump water to our homes. And so if the power grid goes out, soon thereafter we lose access to potable water. And you can imagine how challenging it is to try to boil water if you don't have power.
People died from the cold. They died from needing medical treatment and not being able to get to the hospital because of the icy roads. They died because the power went out and they couldn't operate the medical equipment they needed. Officially, about 250 people died. Unofficially, more than 700 people died from this disaster.
A power outage quickly reveals how our lives are built around energy access. But people can live their entire lives in congested cities or remote areas, plugged into a grid without ever seeing the source of the energy they consume. Behind everyone's electric outlets lies a vast, complex infrastructure that requires constant maintenance. Mismanagement can have disastrous consequences.
California is a state that has been prone to wildfire for as long as the land has been there. That has become more true as the climate has changed. We've seen longer droughts, more intense heat waves, and that has made it so that the risk of a very deadly and destructive fire has become heightened. And all of the state's utilities have had power lines that have ignited large-scale fires over the last 10 years. But some of the most deadly and destructive have been started when PG&E's power lines have failed. PG&E has had a number of challenges over the last 2 decades. There was an energy crisis in California in the early 2000s that ultimately pushed it to seek bankruptcy protection. The few years in which it's emerged from bankruptcy, they were focused on delivering returns to shareholders. The company was also focused on procuring wind and solar contracts, basically at the behest of the state. Wind and solar power were much more expensive than they are today, so the company faced additional pressure to keep expenses low. The company is still tasked with maintaining the infrastructure. It's a sprawling service territory. It covers 70,000 square miles. Part of it involves managing trees that have the potential to touch live wires, looking at the strength of the structures, the integrity of the hardware. In November of 2018, a hook on a transmission tower that was 100 years old broke and dropped a live wire that showered the ground with sparks. The component that broke had never been replaced. The company had known of the risks and yet done very little to mitigate them. It destroyed the town of Paradise and several nearby towns in the Sierra foothills north of Sacramento. 84 people died.
If you look at the three disasters in California, Texas with the freeze, and in Puerto Rico with the hurricane, they seem so different, but they're all part of a broader trend of intensifying weather extremes.
After Hurricane Maria, around 200,000 people left. Some came back, many didn't. I don't think that's something that can be measured in any other way than how important is the access to a reliable energy supply. Do we need to build back what we had before, or do we need to look into the future?
Reliability issues are very challenging, and they actually really don't lend themselves to a clear-cut political narrative. Wind and solar power are inherently intermittent. They don't produce power all the time. You know, fossil fuel-fired assets, they too have reliability challenges. And so, as we change the types of energy that we rely on, comes a whole new set of questions that we need to explore.
We've had a number of energy transitions. The dominant fuel source changed rapidly from wood to coal. However, wood has never gone away. When oil came in, it didn't eliminate coal. The energy transition we're talking about today is different. I would argue that it's not some one-size-fits-all lens, but just the opposite. Addressing the energy transition calls for different regional approaches.
Nature has been practicing engineering for much, much longer time than we have. It has perfected so many aspects of that engineering. We are a living proof of that in so many ways. I think we should look at what nature does and try to mimic it.
In Iceland, I think we've come quite a ways in terms of just recognizing the potentials of all of these resources that we have around us and actually having that transform our way of life completely.
If you think of the Laki volcano in 1783 and how dangerous that would be without energy to deal with it, we don't want to go back to that world. The Icelandic people have taken this very dangerous, powerful force, volcanic eruptions, and harnessed it in a way to get the energy they need.
Here we have the Hellisheiði geothermal power plant, and it's actually one of the largest geothermal power plants in the world. It produces 303 megawatts of electricity, but also about 1,000 liters per second of hot water that is piped to Reykjavik for the district heating system. Even though geothermal is considered green energy, it still emits some CO2. We are developing a method to capture and prevent it from going back to the atmosphere by turning it into stone. Iceland is the perfect spot to develop this method because it is mostly made up of basalt. So it's 90% the rocks that we need to turn CO2 into stone. It's kind of like a sponge, so it's very convenient and it can store a lot of CO2. There is not a solution to the climate change, but hopefully this is one of the solutions that we need.
around the world, we all have a common desire for safety and comfort, peace and prosperity. The rise of availability of modern energy helped reduce suffering and really gave us great civilized quality of life. These energy disasters are scary. From each disaster, there's a lesson to learn. And it's important that while we pursue having more energy available for more people, that we're honest with ourselves and each other about its risks.
As the need for energy grows, so does the risk of disasters. For the first time in human history, the world must come together to face collective energy challenges. On the table are decisions about how to invest trillions of dollars to manage a massive transition in a way that ensures access to clean, affordable, reliable, and above all, safe energy. The decisions being made in this decade will have far-reaching consequences for billions of people over centuries to come.